My name is Johann Zmeskal. I'm a senior scientist in the Stefan Meyer Institute for Subatomic Physics in Vienna. My research interest is devoted to the precision spectroscopy of exotic atoms. The basic idea of such a gem detector is quite simple. In a plastic foil with both sides covered with a thin copper layer, we punch in a lot of small holes. By applying a voltage difference of a few hundred volts, a huge electric field is generated in these small holes. The gem foil is placed in a gas, and a charged particle passing through that gas produces electrons. These electrons are guided by an electric field into the holes and are amplified.
We are in Trentino, in the north of Italy. What you see is the ECT STAR, the European Centre for Theoretical Studies in Nuclear Physics and Related Areas of the Bruno Kessler Foundation in Trento. What role does the ECT STAR play as a transnational access centre for European research?
The importance of ECT STAR for European research lies in its mission. It creates the necessary conditions for excellence and state-of-the-art research in hadron physics by foreign collaborations and bringing together specialists from all over Europe and the rest of the world. It offers furthermore to the European research teams a natural forum for holding workshops and collaboration meetings to discuss results and tackle problems and exchange ideas. It promotes coordination of European research efforts, preventing isolation of smaller research groups, particularly in the less favorable regions of the community, strengthening the mobility of the European researchers and putting them in a strong worldwide competitive environment.
University of Münster in Germany. We are here at the Institute of Nuclear Physics together with Professor Alfons Kukas, who is leading the international future JET activity in the framework of the HadronPhysics2 project FP7. Could you shortly explain how participation in such experiments looks like and how especially young people are involved?
Well, young people, young students and young researchers are actively involved in the preparation of these experiments. This includes, for example, the computer simulations and numerical calculations. And of course, they also participate actively in the experimental runs. Later on, the obtained data get analyzed by these researchers, and so the participants, the students and researchers work as a complete project. Of course, it is important that the participating institutes design and construct special devices for the experiments. And our working group here in Münster, for example, is specialized on cryogenic targets for storage rings.
Welcome to the Faculty of Science of the University of Orsay. I am Michel Guidal, researcher at the Institut de Physique Nucléaire of Orsay. Let's take this tennis ball. It is made essentially of rubber with air inside. Rubber is principally made of a molecule called isoprene, which is an assembly of carbon and hydrogen atoms. These atoms are bound together by the electromagnetic forces of the same nature as the electric and magnetic forces with which we are familiar in our daily lives. The atoms are themselves composites. They are composed of a nucleus surrounded by a cloud of electrons orbiting around the nucleus. The electrons are all those little green particles all around me. Once again, the electromagnetic forces hold the atom. For a long period of time, we thought that nucleons were the ultimate constituents of matter, that they had no substructure. For about 40 years now, we know that they are also composite and that they are made of another class of subparticles, the quarks and the gluons. A nucleon is a very complex object. The quarks, which are the particles of matter, are confined in a very tiny volume, which is about 100,000 times smaller than the size of an atom. The gluons are the vectors of the so-called strong force. The gluons keep the quarks confined in this tiny volume. The strong force is a very different force than the electromagnetic one. As there is an electric charge, there is a color charge. It comes under three forms: red, green,